Hello everyone. In first class we have studied differentiation and integration sign. In that we have studied rule 1. In rule 1 we are having limits as a constant numbers. Now here we are going to study rule 2, Leibniz rule 2, in which I am going to have limits for integral as a functions of this alpha. Alpha is a parameter meaning I is depending on alpha, and this a of alpha and b of alpha, these are nothing but functions of alpha now. They are not constant, they are functions of alpha now. Okay, this is the only change. Then in that case, the differentiation of I with respect to alpha, we are going to do it using this formula. The formula is integral a of alpha b of alpha partial differentiation of x comma alpha with respect to alpha. This term is same as in the rule 1 also. The next part is little bit different. In this case, the next term is f of b alpha. B meaning I am substituting instead of x this upper limit b and alpha as it is into derivative of this b with respect to alpha minus, and this derivative must be the regular derivative because it just depend on alpha, and minus f of a comma alpha into derivative of a with respect to alpha. So this is the rule. Now how to implement this rule? Let's see the first example based on this. What we need to show that this phi of a integral, when I am evaluating this integral, it comes independent of a. Independent of a means answer should not contain a. Okay, let's try to solve this using this method. Okay, why I am applying rule 2 here? Clearly this is phi of a and limits are as a functions of a here. A is present in the limits, that means limits are as a functions of a. So I cannot apply rule 1 here because they are not just constants now. Okay, I need to strictly apply rule 2 here. Okay, so depending on the constant or the functions, you are going to choose whether this is depend on rule 1 or rule 2. Okay, let's start solving the question. What do we have? Phi of a, this is equal to integral pi over 6a to pi over 2a sine ax divided by x dx. Differentiate this with respect to a. What do we have? This is integral pi over 6e to pi over 2a derivative of sine ax by x with respect to a dx as it is, plus in the formula what do we have? F of b comma alpha. F of b comma alpha means instead of a I am going to substitute pi by 2a. Instead of x, I am going to substitute pi by 2a. So this is sine of a into pi by 2a. This is divided by x is nothing but pi by 2a into derivative of pi by 2a with respect to a. Derivative of pi by 2a with respect to x. This is a regular derivative. Minus the next term is substituting at x is equal to pi by 6a. So this is sine of a into pi by 6a. This is divided by x is pi by 6a into derivative of lower limit with respect to a, that is pi by 6a. I'll repeat the procedure one more time. What we did here, differentiation of this with respect to a, the first term derivative of a with respect to a as it is, plus the next term is evaluating this function at x is equal to pi by 2a multiplied by differentiation of this with respect to a minus, now the term is lower term, that is substituting x is equal to pi by 6a here, and you are going to get this term into derivative of lower limit with respect to a. So let's simplify this further. So this is equal to derivative is pi by 6a to pi by 2a. Derivative of this with respect to a, so x is just a constant, so this is 1 by x multiplied by derivative of this with respect to a is cos a, this is multiplied by x dx, applying chain rule for this term, into this is nothing but a will get cancelled here, this is sin pi by 2 divided by pi by 2a into derivative of pi by 2a with respect to a, pi by 2 is just a constant, derivative of 1 by a with respect to a is minus 1 by a square, minus this is sine of pi by 6 divided by pi by 6a into derivative of pi by 6a with respect to a is nothing but minus of pi by 6a square, that is derivative of 1 over a with respect to a is minus 1 by a square. So this is equal to x get cancelled, the remaining is integral of cos ax, integral of cos ax is with respect to x is sin ax divided by a, this is from pi by 6a to pi by 2a, plus sin pi by 2 is 1, so this is 1 over pi by 2a, pi by 2a, this will get cancelled with pi by 2a here, and only one a will remain, that is minus 1 over a, and this minus and this minus become plus, and sine pi by 6, this is nothing but 1 by 2, so this is 1 by 2, and pi by 6a will get cancelled with pi by 6a, what remains? Just 1 by a, right? Let's try to simplify this further. So there I am having, this is equal to sine of, I am substituting upper limit, so a times pi by 2a minus sine of pi by 6a into a minus 1 by a plus 1 by 2a, and this is equal to a get cancelled, so this is just 1 minus, and the whole thing, I'm sorry, this is multiplied by 1 over a. Now this is get cancelled, sin pi by 6 is 1 by 2, and this is just minus 1 by 2a. So this is 1 by 2a minus 1 by 2a, and which is 0. So we have shown that the given integral, this is equal to 0. Since a is not present in the answer is independent of a. So that's it, the procedure.